For anyone just joining us, we've already checked the evens. Let me zoom in real fast on homework 61. Did I have the numbering right, guys? I got off last week somehow. Is 61 right? Can you look back in your spirals real quick? Did it go 59, 59, 60, or did it go 59, 60, 61? Okay, there were two 59s then. That was my bad. There was a 59 in the last section. So it should be 60, 61 for 10, 1, 10, 2. Does that make sense? Does that work with what you have had? Okay, 59 was 9, 7. I messed up on the homework sheet. Let's get to it. Okay, so anyway, sorry, those of you guys I wanted to make sure we were all good on the numbering. I think I changed it like Friday and I didn't mention it to you guys. I noticed it later. So we had B and F and then C and then number 36, pause it if you want it because I am leaving the screen. Okay, so you guys had questions. First of all, on number 15. Let me get it over here so we can look at it. Number 15 says, find an equation, basically, right? Yeah. Okay, is the x squared or the y squared if it's up, down? I know, it's been a weekend. Hang in there with me. Up, down, x squared or y squared? X squared, it's the normal one. So we're going to just stay on number 15. But we're going to have x minus the vertex of the x, which is just 0, 0. So 0 for the x equals 4 times p. I'm not quite sure what that is, but I know the y value of the vertex is 0. So we almost have everything. The only thing we're missing is p, and what extra piece in number 15's graph did they give us? A point. And so we have x is 3, when x is 3, y is 6. So couldn't I find p? Couldn't I kind of go off to the side and say, okay, fine, let me test this 3, 6 point? See what I mean? Take the 3, take the 6, plug and chug. After pretty quick manipulation, you end up with 9 and you would divide by 24, so p would end up equaling 3/8. Does that sound right? Yeah. So all we have to do is just plug and chug, so x squared equals 4 times 3/8 would be good. 3 halves 1. Okay, number, you guys went down to 27. Similar idea in that they give us clues and we're trying to find the equation. But in this one, they say horizontal axis passes through the point -2. Oh, all of these have a vertex at the origin. I missed the directions. All of these have a vertex at the origin. So we basically start with a very similar beginning, except if it has a horizontal axis, what on earth are they talking about? What axis?
It's like this axis that goes through.
Yeah, which is called the axis of symmetry.
Oh, darn it.
Were you close?
No.
What kind of axis of symmetry does this up-down one have? Vertical. What kind of axis of symmetry does this right-left one have?
Horizontal.
Yeah, so when it says horizontal, I know, oh, not x squared, y squared. So we would just change this up and say, oh, we have the y over on this side now. From the directions, the vertex is at the origin. At this point, what am I going to do based on what I did in 15? Plug and chug for 2. And the clue is -2, 5. So plug in 5 for y, -2 for x. Solve, solve, solve. What did you guys end up getting for p?
1/3.
So at the end of the day, after plugging in the clue, which is over here, -2, 5, we end up with y squared equals 1/3. Oh wait, p is 1/3. Sorry, 4/3. 4 times 1/3 would be 4/3. Is that good? Okay. Number 41 was, I think, out of all the questions you guys have asked, I think 15 and 27 were similar. You got stuck on the plugging in the point. And then number 41 was hard for a totally different reason. Because number 41 gave you your old nemesis from Algebra 1. Complete the square. Just looking at that expression, kiddos, you should know who's being squared, the y or the x. The y is the only squared one, right? So I'm going to go ahead and on the left side, y squared plus 6y plus, because from all those standard forms earlier, the squared one went on the left. On the right, I'm going to move the -8x and the 25 away. I complete the square, which is what I'm intending to do, but if I
How did that
when I add to one side, I add to the other, it like automatically select. How would I complete the square? Take the middle, 6, divide by 2, 3 squared, 9. Nothing on the outside for me to stress about, so if I add 9 on one side, how do I keep it balanced? Add 9 on the other. I end up with y plus 3 quantity squared equals negative 8x minus 16. Ooh, that's nice. What can I do here? And why am I factoring out? Can they just help me out with this? Why would I factor that out right now? Standard point. I have my vertex of negative 2, negative 3. I have my p of p equals negative 8. P is equal to divided by 4, negative 2. I can find my directrix. I can find my focus. This is, oh, there you go. Quick hint, number 49 is just like number 27 and 15 in the sense that they give you a clue before I finish this problem. They give you a vertex you plug in, and they give you a point you plug in, x and y, and solve for p. Okay, so that finish this problem. So you can go ahead, it's up to you guys, once again, I like putting things in a graph to visualize. I know my vertex is negative 2, negative 1, 2, 3 from my h and k. I know 4p equals negative 8, which means p equals negative 2. Since the y is squared, I know it's a right left, but since the p is negative, I know it's a left. So since it's going to be heading this way somehow, obviously I'm not being super precise, I'm not finding like x-intercepts in order to make it all nice and symmetric. Or I should say, proportion correctly. But I can say the directrix is going to be 2 away from the parabola. It's going to be at x equals 0. The focus is going to be 2 inside the parabola, which is going to be the point negative, wait, 2. Yeah, negative 4. And my vertex, of course, as we already said, was negative 2. And that checks off that. Sketch the parabola. Sure, I won't judge. Yeah.
Can you go back to 27? I missed it.
I already erased it. It's in the abyss. Hey, the video. There you go. Alright, cool kids, have your homework spirals open to this homework unless you were gone on Friday, and then when I come around, make sure you tell me you were gone on Friday and that I can back that up with proof. Meanwhile, back at the ranch. Does anybody actually know that reference anymore?
Can you tell me what makes random spot checks?
Huh? Oh, there's going to be a spot check every day this week so that you don't
Every
totally
day
suck
this
up.
week?
Well, every day there's homework due, which means today and Wednesday.
I have to do homework.
Aw, struggle, man. That's exactly the point.
Oh, it's
But I use it in review.
Alright, kiddos, you should have this page hopefully down.
put X, comma, Y.
More seconds. I'm going to change the slides so you guys can keep on getting the format for today. Meanwhile, I'm going to rush around and spot. And
There's no spot
we
check
should get
tomorrow.
this in our first
Yeah,
class.
there's every day of the week.
There's homework.
Every day that there's homework due. Yeah.
Yeah.
Good listening.
I don't pay attention in class. It's part of the problem.
Spot checks too. That's what they're talking about. What do you think is the most common thing to go missing from a math teacher's desk?
The stapler.
Pencil.
Pencils.
I call it.
Well, I use your stapler most, so I would say stapler.
Ah, but does it go missing?
That's true.
Pencils don't
Responsible.
return.
Wouldn't that be true with any teacher's desk?
That's true.
Do you use pencils in every single class?
Just about.
Pretty much.
No, because that's weird.
I mean,
This
they
is
just have to
disgusting.
stand pants, or just whatever I feel like.
Thank you. Depends.
Okay, you guys ready now? You're all
On
talking.
the ground. Yeah, it looks well.
Okay, ready, set?
I didn't realize what.
Just like the parabola kiddos, this is just like a description of where an ellipse comes from. I'll try to demonstrate it either today, maybe tomorrow, because of time and stay sharp all day. We are going to fill in the standard form of the circle. We can do that right now before I start spot checking. Actually, I don't remember. I looked at it very quickly today. You guys remember standard form of the circle, kind of, like it's back in your brain somewhere, right? Oh, one yes.
Yes.
This is one form of a circle. However, thinking about conic sections and thinking about how they're all equal to 1, technically, to make this equal to 1 for our clue form, we would divide everybody by r squared. Just rearranging standard form just a little bit, that is another variation of the standard form of a circle. And what I want you guys to realize is that both of these denominators for a circle are the same. But what do you think is going to be true for an ellipse? They're not going to be the same. The circle has one constant radius all the way around. The ellipse does not.
What is it?
It has a constant relationship of whatever the distance from one focus and the other focus are added together. There's a constant sum of the two distances from the foci. However, alumni? Alumni. Anyway.
What's the singular form of one?
Alumnus.
Alum.
Alum.
You can say alum. That's easier. I'm an alum. But as you guys go around, it's not one constant radius. So what's going to change with an ellipse is those are not going to be the same. They're going to be two different constants. Let's go ahead and go get that standard form of an ellipse. You guys see it? Let's see if I can do that better. All right, get down what you can. Ricky, you were absent.
Yes.
Jacob, you can.
So I have to do 10-1 and 10-2 by tomorrow.
10-1 by tomorrow. Oh, wait. Technically, I've just spot checked the first one. Oh, you were gone on Friday, right? Oh my
You
goodness.
did it.
Yeah.
Show off.
You got time, but you didn't, you're supposed to.
It's like the first time I did it.
You were gone too, right? So you just had one.
Are you gonna roast me?
Are you
Go ahead.
feel free, but we can keep it inside.
I'll play later.
You did the influence. It's always an easy shot.
Yeah.
It's not good.
Did you do your weird square thing?
No, it's worse.
I was gonna say,
Can we get a formula card for the test?
Please say we get a formula card. Please.
We have all spring break to study then.
I have to do a Mrs. Choi project.
That's true,
Oh,
we do have to do
yeah.
that.
Which one will take more time? Memorizing a few math formulas by like the Wednesday after you get back,
That.
or Mrs. Choi's project?
That. No, not the Mrs. Choi project.
I was to honestly ask your opinion which one you'd rather have.
I'm doing one of those.
Yeah.
So I'm gonna do
I prefer the beginning. Because the end is Easter. Wait, no.
You mean to zoom in?
The beginning is Easter.
Yes.
Well, if you're covered.
I don't think you can I haven't heard like anything about
Okay, who's in your group?
Okay.
Nathan, Jacob, me, Josh.
Ashley.
so
And
this was supposed to be
Dude, I better see some sanctuary.
Anyone who got zeros today, meaning you didn't have 10-2 ready, if you have it ready tomorrow when I check. If you have it ready Wednesday when I check. How many of you guys, sophomores, where are you at? Oh, you guys all did your homework. They're fine. On Wednesday, let me just spot check when I'm spot checking 10-3 on Wednesday. I'll spot check your guys' 10-2 who didn't have it like late this week, and you'll still get your half points. Sound good? Okay, just have it ready and make sure when I come by and be like, oh, here's my 10-2 also, and I'll mark you down. And then absent people, for sake of time, we'll just do yours on Wednesday too.
Oh, how nice.
Oh, you have it ready yet?
There's so many
I'll get back to you.
formulas.
Alright, kiddos, you have your formulas down for ellipses. Tyler, you're still complaining.
Yes.
Well,
You never stop. No.
Alright, let's stop the judgment, although I started it. That's actually awesome.
Come on.
That's how we got Gabby to say yes.
Rick,
I'm sorry.
you just asked me.
It was right there.
He has to make up for the roast he didn't say.
Yeah.
I'm not sure that's a healthy perspective on life.
Thank
Alright, okay, so we go. Alright, cool kids. The only thing we missed on this back page, it wasn't too much, was the visualization. I'll show you guys tomorrow, no big deal, when it's not chapel day, as to how an ellipse comes about. It's kind of similar to a compass, like for a circle, but you need two foci and not just one center. So we'll talk about that tomorrow. But we do have our equations, and if you guys notice, like I said, ellipses. Which one's a grammar term and which one's math? Singular and plural? I don't know. But as I said, if it's an ellipse, every circle is an ellipse, but not every ellipse is a circle. Does that make sense?
Okay.
Meaning,
Yeah.
an ellipse needs to be in this form, and a circle can be in this form as long as b squared equals a squared. So a circle is a special type of ellipse. But an ellipse is not a circle necessarily, because an ellipse usually has different coefficients in the denominator for the x term and the y term. Now, what else you should notice is that unlike the parabola, and similar to the circle, an ellipse has two squared terms. So there's going to be an x squared term and a y squared term. And typically their denominators are different. If they are the same, it's a special case of a circle. And like other conic sections that we're going to see, you have one isolated, kind of like I showed you in the very beginning with the standard form of the circle, divide by the radius squared, and you you get a 1. Now, what's also different about an ellipse is since it's not a circle, and since it's not going to have, or I should say, not every ellipse is a circle, most ellipses aren't, it won't have one constant radius, so therefore we have two different diameters. You can think of it that way. We have two different diameters. We have a major one, and if you guys notice, in this ellipse, the horizontal is the major, and in this ellipse, the vertical is the major. What do you think major refers to?
The bigger one.
Literally, just the bigger one. Literally, just the bigger one. And so, from these, if you guys got a little stuck in your formulas, A is referring to the major. Now, I'm going to put this in quotation marks. The major radius. Because if I was to zoom in, A is going to be half the distance. It's not going to be all the way across. The major axis itself, the entire thing, is like the major diameter. It's going to be the entire distance from one vertex to another. But A actually refers to half that distance, so I call it the major radius. It kind of makes sense, like cut the diameter in half. B, on the other hand, is going to be the minor radius. Other terms you should probably highlight or make sure you take note of. The vertices of an ellipse are the points on the outermost circle of the ellipse at the ends of the major axis only. I guess you could say there are minor vertices, there are major vertices, but if they ask for the vertices, they're asking for both ends of the ellipse along the major axis. And besides that, we have what we have for circles as well as parabolas, the center. Okay? So we have A is our major radius, we have B is our minor radius. Once again, I'm putting it in quotes because is it technically a radius if it's not a circle? I've seen some books call it a radius, but other ones don't. And then what else did I define? I defined HK to be the center. Let's see, anything else? A to be the major radius, B to be the minor radius, HK to be the center, and the vertices are at the outermost parts of the ellipse along or at the ends of the major axis. So I'll go ahead and really quickly highlight this one up as well. We have the vertices at the ends of the major axis, we have the center in the very, very middle, our HK. Our A on this one is going to be vertical instead because A is going to be the major radius as well. Now it's just oriented differently. And B is going to be the minor radius, which is going to be horizontal on this one. So the reason that these two variables switch is just because A in ellipses, for the most part, just refers to the major. But the nice thing is you'll just see them as numbers. They won't necessarily be labeled as letters. And so you're just going to look at them and say, oh, hey, that one's bigger. Okay, it must be a major that's, if it's under the Y, vertical, or if it's under the X, horizontal. Tyler, go ahead.
What if it's like rotated so that the axes of the circle don't line up with like the graph?
With an X or with a Y, that's going to have a different axis rather than horizontal vertical. That would be like section 10.5 where they're rotated. Let's keep going. What we didn't talk about in the graph before, and technically guys, if you want, you could just put them in that graph where everything is labeled. You don't have to make new graphs. But just for sake of, there's a lot going on. Well, there's a lot going on. Hold on.
Rest in peace.
Rest in peace. Who's resting in peace? You're trying. You try to get rid of notifications because they're annoying you in class, and then like your Gmail pops up about the teachers you're talking about from. Okay, so.
Like Mrs. 26.
She dances every year.
Mr. Strike Dance.
Yeah.
How was that?
I was like,
Okay, so back to the foci. If you guys do want to put them, they are going to be points equidistant from the center along the major. Where are you? It's coming. There's one. Equidistant from the center along the major axis. So there are going to be two foci, one to the left, one to the right, if the major axis is horizontal. And similarly, if the major axis is vertical, The foci are going to be equidistant from the center again, but along the major axis again. Hence, for the second one, they'd be along the vertical. Now, how far away are they? Similar to the parabola, in that the little constant p was what was helpful for getting us the distance from the vertex to the focus. In ellipses, there's going to be a new letter c. This looks kind of like the Pythagorean theorem if you think about it. There's going to be a new variable c that tells us the distance from the center to the foci, or to the focus, I should say. And that distance, you can go to the right and hit one focus, you can go to the left and hit the other focus, pretend those actually look equidistant. Similarly, if it's vertically, we'll just use that c to go up to a focus and down to a focus. So if I were you, if you are the highlighting kind of person, the starring, boxing kind, I would definitely highlight this formula. It is a big one for ellipses. C squared, which is the distance to the focus from the center, is equal to a squared minus b squared, where I have a being the major radius minus the square of a being the major radius minus the square of b being the minor. Okay. Makes it more fun. It's not often. Examples. So, they give me an ellipse, and they give me basically all of the little vertices in the sense of the major vertices and the minor. Remember, if they say vertex, they're talking only about the major. I'm pretty sure the center is understood, right, guys? What do you think the center is?
0, 0, possibly.
Totally agree. Geometry says not to trust the picture. Good thing they say the center at the origin, so I guess we can trust the words. Huh? So,
Trusting is bad. Amen.
trusting is bad?
Trusting.
Only when you trust in the wrong things. Like,
Such as the graph.
True.
yeah, I would say I would like to trust a graph is not necessarily the wisest.
So let's not do it.
In a life philosophy. But
Burn the graph.
if you have no other references to trust, like on an SAT, probably just kind of go with what you got. Kiddos, we can go ahead for an ellipse and say, sweet, you know what? We have x minus plus y minus, just think of a circle, equals 1 with little fractions. We can do x minus, we can do y minus. For an ellipse, since addition is commutative,
Good job.
since addition is commutative, we're always going to put the x term first. For hyperbolas, there's this whole thing with subtraction, and it kind of matters which one comes first. But for addition, it doesn't, so we're just going to always put the x one first, just for sake of that's what we did with circles, and it's going to be easier to remember. We already talked about center of the origin. Can't we put in 0, 0? Okay. What can we put for A?
A is 2.
A is 2, and should that go under the x minus 0 squared term or the y minus 0 squared term?
Actually, 0.
Good, because easy way to remember,
That's the major.
horizontal. It's horizontal. Whether it's major or minor, it needs to go under the x. So whether it's big or whether it's little. So even though we talked about major and minor, even though it's kind of important if they ask you questions about major and minor or vertices, etc., just think horizontal one's going to go, the horizontal radius is going to go underneath the x term, so what's going to go underneath the y term? Yeah, the vertical one. Now, technically, kiddos, that's a great equation, and if I boxed it, I would not be wrong if it was like a long answer. However, if it was multiple choice, it would not look like that.
Rearrange it so it's
What would it look like?
X squared.
Oh, 3. Got it. Oh, I know.
Where did those come from?
times 9 times 4.
Okay. Here's something that commonly happens with ellipses, because just think about how the radii don't always seem to be like nice whole numbers. I mean, this one over here was nice. It was 2, so I was able to plug in 2 squared. 2 squared is 4. It's nice and pretty. But the b was a little bit different, right? Because it was 3 halves. And when you plug in 3 halves and when you square 3 halves, what do you get? Okay, 3 over 2 times 3 over 2 is 9 over 4. So if I was to write this, the in-between step, y squared over. How did I get 4 over 9 if it's divided by 9 over 4? Multiplied by the reciprocal, division by a fraction. So y squared divided by 9 over 4 is y squared times 4 over 9. And then how did I jump from the one on the left, which is once again a very good form, and in most circumstances, most purposes, that would be sufficient. How did I jump to this other, more standard form? Couldn't you get common denominators?
Yeah.
If you get common denominators, wouldn't you have a 36? So if you use my cool nifty trick, couldn't you have multiplied both sides by cos the common denominator and simplified? That's how I got it. Alright, cool kids, thanks for letting us get through. One good example, we have to cover some more later. 5, 4, 3, 2, 1. Bye guys, see you later. Yes, at 3:30, my door is locked and you can't come in. There's going to be a super top secret
More
reading
AP stuff?
FRQ.
Okay, well, someone left all their stuff under my desk, so
Oh,
there's that.
I think that was actually from Friday. I don't even know.
Who knows?
Let's do it.
Bye all.